velocity head of water is equal to pressure head of 40 centimeter of mercury. They given here, the question when simples to be, understand velocity head of water is equal to pressure head of 40 centimeter of mercury. I told her velocity head when we use v square by 2g, v by rho g is a pressure head. G cancels. So it is a density of water, v by rho. But this may be written as H rho of mercury into G divided by rho of water. They are asking at what speed. V is a question. V is equal to root of 40 centimeter, 40 into 10 power minus 2. Density of mercury 13,600. G is 10 divided by density of water 1000. If you simplify here, all the 3 goes to this 3 and minus 1, 0.4 or 13.6 into 4 root of multiplied by 2 is 8. This becomes 4 2 is 8, 8 and 108. This leads to 10.3 meter per second. We left here 2. This I taken again here and final answer going to be 10.3 meter per second. Option number 1. A level 3 question. Velocity head equal to pressure head. But very carefully is pressure head when we say it is of mercury. Originally it was of water. Substitution and I think the answer is 10.3. A manometer connected to a closed tap reads V1 is 3.5 into 10 power 5 Newton per meter square. Closed tap inclines velocity V1 is 0. Tap is closed. When the valve is opened, reading of the manometer come down to 3 into 10 power 5 Newton per meter square. What is V2? Manometer falls to. Same previous, it is level 3. V1 square by 2 plus V1 by rho is equal to V2 square by 2 plus V2 by rho. V2 square minus V1 square is equal to 2 into V1 square minus V2 square equal to V2 minus V1 divided by rho. So V1 they given is 0. Therefore minus V2 square is equal to 2 into 3 minus 3.5 into 10 power 5 divided by 1000. This minus 0.5 into 2 is 1. That become 100. 10 power 5, 10 power 3 cancels. V2 square is V2 is equal to 10 meter per second. Option number 2. The fourth unit is about viscosity. Question number 2. If the radius of the tube is doubled, the rate of flow increases by R2 is 2R1. V2 is how much? V1 is V enter. You know from Poisson's formula V proportional to R to the power of 4. Therefore V2 by V1 is equal to R2 by R1 power 4, which is equal to 2 power 4, which is 16. V2 is equal to 16 times of V1 Option level 2 question. Answer is 16 times. Option number 2 is right. Directly Poiseuille's formula leads to V proportional to radius to the power of 4. A steel ball of mass m falls in viscous medium with a terminal velocity v. Another steel ball of mass 64 m will fall through the same liquid with terminal velocity. I say it is level 3 because you will come to know. Steel ball of mass m falls with viscous medium, terminal velocity v. M is v. When m1 is m, v1 is v. When the mass 64 m, m2 is 64 m, what is the terminal velocity? That is in terms of v present. Once we see this, terminal velocity is proportional to r square. We have a relation 2r square g upon 9 eta into rho g rho s minus rho l. When we write this, v2 by v1, v2 is required. Directly can say r2 by r1 whole square. But the problem is that not available. But here the mass given, I have to bring r in terms of mass. How? Again you go, mass is volume into density 4 by 3 pi r cube into, that needs another level extra. So this suggests m is proportional to r cube. That means where r is proportional to m to the power of 1 by 3. Now I can write this as m2 by m1 to the power of 1 by 3 power square. Our answer available. What is m2 by m1? m2 by m1 is 64 m by m to the power of 1 by 3 to the power of square. 4 cube is 64. 4 square is 16. So V2 is equal to 16V. Answer available is the fourth option. That is why we put in level 3. There is a relation V proportional to R square. In velocity, terminal velocity relation, we are not finding the mass. But mass relation is with the radius. Radius dependency is a radius proportional to cube root of m. Apply for R cube root and find the answer. That gives you the final solution. A spherical solid ball of volume V is made of a material of density ρ. It is falling through a liquid of density ρ2. Assume that liquid applies a viscous force. That ball is proportional to the square of the speed. Force of viscous is. The given force of viscosity is minus kV. You neglect the sign, kV square. So their volume is given. Volume of density is 4 by 3 pi r cube into rho is a volume 4 by 3 r cube. Here answer is available in terms of volume and density. The kV square is equal to 6 pi eta r Vt. Terminal velocity. I come to this. This is equal to 6 pi eta r into terminal velocity is 2 r square g upon 9 eta into ρ1 minus ρ2. This kV square as it is. 6 2's, it is 3 times. 4, it becomes 4 by 3 pi r square into r is r cube into g ρ1 minus. This is nothing but volume we take. Therefore V is equal to, this V equal to 4 by 3 pi r cube is V into g into ρ1 minus ρ2 by k into square root. This is volume, this is velocity. Option number 2 level 1. This is again level 3. Even the formula is manipulated, confusing with V terms. One is volume, one is velocity. One is terminal velocity, speed. The different are there. kV square is 4/6 pi eta r Vt. Vt substitute as per the Stokes formula. 4/3 pi r cube is becoming volume. Substitution get you the final answer. A small spherical ball falling through a viscous medium of negligible density has terminal velocity v. Another ball of same mass but of radius twice that of the earlier falling through the same viscous medium will have a terminal velocity. R2 is R1. When you see the terminal velocity in this, directly suggests that it is proportional to R square. But the problem is mass. Same. Our duty is to bring, the word is more important in this question. Terminal velocity is 2r square g upon 9 eta into rho minus g. It is neglected. Neglected the density of the liquid. Density can be written as mass by volume. It is a sphere. 9 eta. Mass by volume. 4/3 pi r cube. I removed this density by term of mass. Why I brought? Because mass must be made same to understand terminal velocity. When I brought the mass, volume made answer V proportional to 1 by R. The logical change. Instead of R square, R cube comes. When you make mass same and V proportional to R square failed, now V proportional to 1 by R. Only this term made the change in the problem. In this case, V2 by V1 is equal to R1 by R2. V2 is equal to V by 2. Because R2 is equal to R1 by 2. Therefore, answer is V by 2, option number 3. Hence, we put in level 3. So, here radius is doubled, mass remains same, density of liquid is neglected. See the velocity dependence on radius changes and take the ratio. Is the solution. The terminal velocity of a spherical ball of radius A falling through a viscous liquid is proportional to. So it is a direct question, level 1, V proportional to A square. Question number 13. Two raindrops reach the earth with the different terminal velocities having ratio 9:4. Then the ratio of their volumes. V1 by V2 is 9:4. The question is on volume. V1 by V2 is R1 by R2 cube. But this can be written as V1 by V2 is R1 by R2 whole square is equal to 9 by 4. Therefore, R1 by R2 can be written as 3 by 2. So, R1 by R2, if I substitute as 3 by 2 whole cube, this becomes 27 by 8 is the answer. We found the volume ratio from velocity ratio. Terminal velocity, find radius ratio, substitute here and get the final answer as 27 by 8 is the fourth option. It is under level 3. Water in a river 20 meter deep is flowing at a speed of 10 meter per second. At a depth of 20 meter, velocity of flow is 10 meter per second. The shearing stress between the horizontal layers of water in the river in meter per second is coefficient of viscosity of water given, that is equal to 10 power minus 3 SI unit. Question, when you see they are asking about shearing stress. The word stress when comes, don't keep your eye on only the fluid dynamics or fluid mechanics. In elasticity, stress is nothing but equal to force by area. So this H you take it as dx. V you write it as dV, you are given eta, which help you because Newton's formula you have studied A into dV by dx into eta is F. Now you can write eta into dV by dx. That gives you the solution more simple. So in that case, eta is 10 power minus 3, 10 divided by 20, cancels. Answer available is 0.5 into 10 power minus 3 Newton per meter square. Option number 4, level 3. Because lateral thinking here, sharing stress, when you think in fluid dynamics, you cannot have a solution. But concept of stress is force by area. This force by area take into equation of Newton's formula A dV by dx into eta. You are given coefficient of viscosity, velocity and distance, substitute and find the answer. Is a level 3. The velocity of a small ball of mass m and density d, 1, when dropped in a container filled with glycerin becomes constant after some time. If density of the glycerin is d2, then the viscous force acting on the ball is. So whenever we take a liquid and a ball is made to fall, it attains terminal velocity when mg become equal to force of buoyancy plus viscous force. Mg equal to force of buoyancy plus force of viscous. Viscous force is equal to mg minus force of buoyancy. Answer is a level 3 question, no doubt. This mg, you can write it as a density d1, volume into d1 into g, force of buoyancy, its volume is, density is d2, weight of liquid displaced, volume same, density changes, it is of liquid, it is of solid. M is brought in the answer. If you see, M is there, mass of the body given. Therefore, Vd1 bring out, Vd1g you bring out, it becomes 1 minus d2 by d1. But Vd1 is the mass of the solid steel ball, mg into 1 minus d2 by d1. Answer available, option number 2 is a level 3. It is mass of the steel ball into g. Here weight of the liquid displaced, mass of the liquid into g, gives you viscous force according to this balancing equation when it attains the terminal velocity. That made Vd1 is a mass and final answer is obtained. Thank you.